To improve your chances of passing the Washington Residential Admin Test, Section 3, focus on several key areas. Firstly, understand the 75% rule. If a circuit has 4 or more outlets, the demand factor is reduced to 75%. This means you'll multiply the total load by 0.75 to account for the fact that not all outlets will be in use simultaneously at full capacity. Secondly, find the correct demand factor for cooking equipment. Refer to Table 220.55 in the National Electrical Code, or NEC, for specific demand factors based on the type of cooking equipment you are dealing with. The NEC provides various tables and calculations for determining the appropriate demand factors for different types of cooking appliances, considering their usage patterns and potential load variations. It's crucial to select the correct table based on the equipment type and the number of appliances. Thirdly, omit the house load and laundry. Unless specifically stated otherwise in the test question, do not include the general house load or laundry circuits in your calculations. These are typically separate calculations and are not part of the specific scenario presented in the question. Fourthly, consider cooling and heating loads. If a home has central air conditioning or heating, you may need to subtract the appropriate demand factor. For example, it might specify subtracting 50 amps for air conditioning. This accounts for the reduced load on the service when the heating or cooling system is operating, as these are typically the largest loads in a residential setting. Taking classes for the Washington Residential Admin Test can be beneficial. While classes are not a mandatory requirement for passing the test, they can provide additional guidance and support. Consider these options. Master Electrician Training Academy, or META, offers a comprehensive online course specifically tailored to the Washington Admin Test. This course may cover all the essential topics and provide practice questions to help you prepare. Washington Electrical Apprenticeship and Training, or WEAT, provides in-person training programs for aspiring electricians. Although the Residential Admin Test is not explicitly mentioned in their curriculum, the fundamental electrical knowledge gained through their programs can be valuable. Electrical Academy Northwest, or EAN, offers a variety of electrical training programs, including a course on residential wiring. This course can provide a solid foundation in residential electrical systems and help you understand the NEC requirements. In addition to the above tips, here are some additional strategies to improve your test-taking skills. Firstly, practice with sample tests. Take multiple practice tests to familiarize yourself with the format and question types. This will help you identify your strengths and weaknesses and allow you to focus on the areas where you need improvement. Secondly, use a calculator. Ensure you have a reliable calculator for accurate calculations. The electrical calculations involved in the test can be complex, and a calculator will help you avoid errors. Thirdly, double-check your work. After completing the test, take time to review your answers for any errors. Make sure you have correctly applied the demand factors and performed the calculations accurately. Don't give up. Passing the test can take time and effort. Stay persistent and keep practicing until you succeed. Remember, the key to passing the test is to have a thorough understanding of the NEC and the specific rules and formulas applicable to residential electrical installations in Washington. While classes can be helpful, they are not mandatory. With proper preparation and dedication, you can pass the test without additional coursework. Let's delve a bit deeper into each of these points to give you a more comprehensive understanding. Regarding the 75% rule, it's not just about having 4 or more outlets. This rule generally applies to circuits serving receptacle outlets for general use. It is less applicable to dedicated circuits for specific appliances. The reasoning behind this is that the likelihood of all general use receptacles being loaded to their full capacity simultaneously is low. Therefore, the NEC allows for a reduction in the calculated load. When finding the correct demand factor for cooking equipment, remember that the NEC Table 220.55 provides different demand factors based on the number and rating of cooking appliances. For instance, a single household range might have a demand factor of 8 kilowatts, while multiple ranges would have progressively lower demand factors as the number of ranges increases. The table also differentiates between ranges rated less than 3.5 kilowatts and those rated higher. Be meticulous in selecting the correct row and column in the table based on the specifics of the question. When omitting the house load and laundry, be sure you understand what constitutes these loads. The general house load typically includes lighting, small appliances, and other miscellaneous loads not specifically called out in the question. Laundry circuits are those dedicated to washing machines and dryers. These are usually calculated separately using specific demand factors or load calculations according to the NEC. Do not include these unless the question explicitly directs you to do so. When considering cooling and heating loads, the subtraction of 50 amps for air conditioning is a simplification and may not always be accurate. The actual load of the air conditioning unit should be determined from its nameplate. You'll need to convert the volt-ampere rating of the air conditioner to amps at the service voltage. The NEC provides guidelines on how to calculate the load of air conditioning and heating equipment, and it is crucial to follow these guidelines precisely. The value you subtract should be based on the actual load of the equipment and not a generic value. When it comes to the Master Electrician Training Academy, or META, and other training programs, it is important to check the course syllabus to see exactly what topics are covered and whether they align with the content of the Washington Residential Admin Test. Some courses may be more comprehensive than others, and it's worth comparing the content and the instructor's qualifications. Look for courses that specifically address the calculations and code requirements that are most frequently tested. Using sample tests effectively involves more than just taking them repeatedly. Analyze your mistakes carefully. Understand why you got the question wrong and what the correct answer is based on the NEC. Create a study plan to focus on the areas where you consistently make errors. Time management is also crucial, so practice taking the tests under timed conditions to simulate the actual testing environment. When using a calculator, make sure you are familiar with its functions and how to use it efficiently. Practice complex calculations so you don't waste time fumbling with the calculator during the test. Double-checking your work should involve more than just a quick glance. Redo the calculations to ensure you haven't made any mistakes in the process. Pay attention to units and make sure they are consistent throughout your calculations. Check that you have applied the correct demand factors and that you haven't missed any steps in the calculation. With dedication and the right approach, passing the Washington Residential Admin Test is definitely achievable. The key is to have a strong understanding of the NEC, to practice applying the code requirements to real-world scenarios, and to develop effective test-taking strategies. Keep going and you will succeed. One key area often overlooked is the correct application of the service calculation process. Service calculations are not simply about adding up all the loads. They involve applying the appropriate demand factors to various loads based on the NEC requirements. For example, lighting loads have a demand factor, receptacle loads have a demand factor, and appliance loads have a demand factor. These demand factors are based on statistical data about how much of the load is likely to be used simultaneously. Another area that can cause confusion is the calculation of feeder and service conductor sizes. Once you have calculated the total demand load, you need to select the appropriate size conductors based on the ampacity requirements of the NEC. The ampacity of a conductor is the maximum amount of current it can carry safely without overheating. The NEC provides tables that list the ampacity of various types of conductors based on their size and insulation type. You need to select conductors that have an ampacity equal to or greater than the calculated demand load. Overcurrent protection is another critical aspect of electrical installations. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from overloads and short circuits. The NEC specifies the maximum overcurrent protection allowed for various types of conductors and equipment. You need to select overcurrent protection devices that are properly sized to protect the conductors and equipment they serve. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the overcurrent protection device and prevent electrical shock. Bonding ensures that all metal parts of the electrical system are electrically connected together, which also helps to prevent electrical shock. The NEC has specific requirements for grounding and bonding, and it is important to follow these requirements carefully. Voltage drop is another factor to consider when designing electrical systems. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to a certain percentage of the source voltage. You need to calculate the voltage drop in your circuits and select conductors that are large enough to minimize voltage drop. Special occupancies and equipment often have specific requirements in the NEC. For example, healthcare facilities, hazardous locations, and swimming pools all have unique electrical requirements. It is important to be aware of these special requirements and to follow them carefully. The NEC is constantly updated to reflect new technologies and best practices. It is important to stay up to date on the latest edition of the NEC and to understand the changes that have been made. You can take continuing education courses or attend seminars to learn about the latest changes in the NEC. Effective study habits are essential for success in any field, including electrical work. Set aside dedicated time for studying and create a study plan. Use flashcards, practice quizzes, and other study aids to help you learn the material. Ask questions when you don't understand something, and don't be afraid to seek help from experienced electricians or instructors. Test-taking strategies can also improve your chances of success. Read the questions carefully and make sure you understand what is being asked. Eliminate obviously wrong answers and then choose the best answer from the remaining options. Manage your time wisely and don't spend too much time on any one question. If you're unsure of an answer, mark it and come back to it later. Remember, the Washington Residential Admin Test is designed to assess your knowledge of the NEC and your ability to apply it to real-world scenarios. By studying hard, practicing, and developing effective test-taking strategies, you can increase your chances of passing the test and becoming a successful electrician. It is important to review the fundamentals of electrical theory, including Ohm's law, which states that voltage equals current times resistance, or volts equals amps times ohms. This law is fundamental to understanding how electrical circuits work and is used in many electrical calculations. Another important concept is power, which is the rate at which electrical energy is used. Power is calculated as voltage times current, or watts equals volts times amps. Understanding power calculations is essential for determining the load on electrical circuits and for selecting the appropriate size conductors and overcurrent protection devices. Series and parallel circuits are two basic types of electrical circuits. In a series circuit, the components are connected end to end, so the current is the same through all the components. In a parallel circuit, the components are connected side by side, so the voltage is the same across all the components. Understanding the characteristics of series and parallel circuits is essential for troubleshooting electrical problems. Alternating current, or AC, and direct current, or DC, are two types of electrical current. In AC, the current changes direction periodically, while in DC, the current flows in one direction only. Most residential electrical systems use AC. Transformers are used to change the voltage of AC electricity. Step-up transformers increase the voltage, while step-down transformers decrease the voltage. Transformers are used in power distribution systems to transmit electricity over long distances and to provide the appropriate voltage for residential and commercial use. Electrical safety is paramount. Always follow safe work practices when working with electricity. Wear appropriate personal protective equipment, such as gloves and safety glasses. To energize circuits before working on them, and use lockout/tagout procedures to prevent accidental energization. Never work on electrical equipment when you are wet or standing in water. By following these safety precautions, you can protect yourself from electrical shock and other hazards. The grounding electrode system is a critical part of the electrical system. It provides a path for fault current to flow back to the source, which helps to trip the overcurrent protection device and prevent electrical shock. The grounding electrode system typically consists of a grounding electrode conductor, a grounding electrode, and a bonding jumper. The grounding electrode conductor connects the neutral point of the electrical system to the grounding electrode. The grounding electrode is typically a metal rod, pipe, or plate that is buried in the ground. The bonding jumper connects all metal parts of the electrical system together, such as metal conduits, metal enclosures, and metal equipment. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges caused by lightning strikes or other electrical disturbances. SPD divert the surge current to ground, which prevents it from damaging sensitive electronic equipment. SPD are typically installed at the service entrance and the branch circuits that serve sensitive equipment. Arc fault circuit interrupters, or ACEs, are used to protect against arc faults, which are dangerous electrical conditions that can cause fires. ACEs detect arc faults and trip the circuit breaker, which interrupts the flow of electricity and prevents a fire. ACEs are required in many areas of the home, such as bedrooms and living rooms. Ground fault circuit interrupters, or GFCIs, are used to protect against ground faults, which are electrical conditions that can cause electrical shock. GFCIs detect ground faults and trip the circuit breaker, which interrupts the flow of electricity and prevents electrical shock. GFCIs are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. Electrical boxes are used to enclose electrical connections and protect them from damage. Electrical boxes are typically made of metal or plastic and come in a variety of sizes and shapes. The NEC specifies the minimum size of electrical boxes based on the number and size of conductors that will be installed in the box. Conduits are used to protect electrical conductors from damage. Conduits are typically made of metal or plastic and come in a variety of sizes and types. The NEC specifies the types of conduits that are allowed in different locations. Conductors are used to carry electrical current. Conductors are typically made of copper or aluminum and come in a variety of sizes and insulation types. The NEC specifies the ampacity of conductors based on their size and insulation type. Wiring methods refer to the way that electrical conductors are installed. There are several different wiring methods that are allowed by the NEC, such as non-metallic sheath cable, or Romex, metal-clad cable, and conduit wiring. Each wiring method has its own advantages and disadvantages, and the choice of wiring method depends on the application. Lighting is an important part of any electrical system. There are many different types of lighting fixtures available, such as incandescent, fluorescent, and light-emitting diode, or LED, fixtures. Each type of lighting fixture has its own advantages and disadvantages, and the choice of lighting fixture depends on the application. Appliances are a major part of the electrical load in most homes. Appliances can be divided into two categories: fixed appliances and portable appliances. Fixed appliances are permanently connected to the electrical system, while portable appliances are plugged into receptacles. The NEC has specific requirements for the wiring of appliances. Heating, ventilation, and air conditioning, or HVAC, systems are another major part of the electrical load in most homes. HVAC systems typically consist of a furnace, an air conditioner, and a thermostat. The NEC has specific requirements for the wiring of HVAC systems. Renewable energy systems, such as solar photovoltaic, or PV systems and wind turbines, are becoming increasingly popular. Renewable energy systems generate electricity from renewable sources, such as sunlight and wind. The NEC has specific requirements for the installation of renewable energy systems. Smart home technology is becoming increasingly popular. Smart home technology allows homeowners to control various aspects of their home, such as lighting, temperature, and security from their smartphones or other devices. The NEC has specific requirements for the installation of smart home technology. Be persistent and believe in yourself.